Today we will discuss working principle of three-phase induction motor. Now the basic question is why the name is induction motor? Because it works purely on electromagnetic induction. There is no direct connection to the rotor. Here we can see this one is the induction motor, real photographs of induction motor, and this one is the shaft. Shaft is connected to the rotor. The middle portion is rotating. The stationary part is stator. So as this motor, the rotating machine, purely works on electromagnetic induction, that is using the Faraday's law of electromagnetic inductions, the name is induction motor. In transformer, we can transfer energy from one circuit to another circuit without the change of frequency. So in transformer also we transfer power. Here in the stator we are giving supply, three-phase supply, and in between the rotor and stator there is some air gap, and in that air gap rotating magnetic field is produced. An induction motor is the most widely used AC electric motor in industry, pumps, fan, conveyor, and many household appliances. Induction motor is also called the asynchronous motor, as it was pioneered by the Nikola Tesla in late 1880s. As I told, it works purely based on electromagnetic induction. And what is the basic part? The stator, rotor. I will show you the real photographs of stator, rotor, which is available in our basic electrical lab. So stator is a stationary part. You see, this one is the actual motor pole, and this is the stator winding. This is the stator winding. And see this one, this is rotor. It's a squirrel cage rotor. See the bar, this portion and this portion is not straight line. It is little bit skewed. And this end ring, by this end ring, it is shorted. So rotor is the rotating part, rotating inner part. And most common type is squirrel cage induction motor. Aluminium or copper bar are short circuited by the end rings. Small air gap between the stator and rotor. I told you that in the air gap, rotating magnetic field is produced. So if we discuss the working principle, so there are 5 steps. First one is we apply AC three-phase AC supply to the stator winding. Okay, that is, we are supplying three-phase AC supply. That is, these are the phase difference between the RYB. This is 120 degree, 120 degree, 120 degree balance. Three-phase supply is given to the stator winding. And number 2 is 3-phase phase current, that is 120-degree phase difference flowing through the stator winding, produces a magnetic field that rotates at synchronous speed. So as we know, popular term in three-phase induction motor is the synchronous speed. What is the synchronous speed? This is the speed of the rotating magnetic field. And mathematically, this synchronous speed is equal to 120 into F by P. 120 why? Because their phase difference between the two current is 120 degree, and so F is the supply frequency, so N is the synchronous speed is equal to 120 F by P. In the numerical, we often use this formula because this is very important. If you know the frequency and poles, you can directly calculate the speed, that is the synchronous speed. If you know this formula, you can directly calculate the synchronous speed or poles or frequency. So this one is the rotor, this is stator, this is the whole motor. These are available in our basic electrical lab. Three-phase windings are there. Induction current in the rotor what we can see, the rotor conductors are stationary initially. That is, at start, rotor conductors are stationary while the magnetic field is rotating. So there is a relative motion. We know synchronous speed, the speed of the rotating magnetic field Ns is equal to 120 F by P, and speed of rotor, sometimes it is written as N or NR. So there is relative motion between them and the rotor bars. This relative motion induces EMF. That is the voltage in the rotor bars. Because the bar are short-circuited, current starts flowing in the rotor. So why current starts flowing in the rotor? Because the bars are short-circuited. Now torque production due to the Lorentz force. There is the BIL rule. Induced rotor current creates an own induced rotor current as there is rotor current present in the rotor conductor. It creates its own magnetic field. So these two magnetic fields, stator rotational magnetic field and rotor field, interact, and so attraction and repulsion force produces torque that tries to make the rotor follow the rotating magnetic field. So if rotating magnetic field are moving in these directions, rotor field will follow it. Why the rotor never reaches the synchronous speed? Due to the slip. What is slip? Slip is denoted as S is equal to the difference between synchronous speed by synchronous speed minus rotor speed in terms of synchronous speed. So it is into 100%. So if the rotor rotated at exactly the same speed as the rotational magnetic field Ns, there would be zero relative motions. So if there is no relative motion, so no induced EMF, so no rotor current, so no torque. That means rotor will not move. Therefore, rotor always rotates slower than the rotating magnetic field. So in the conclusion, what I want to say, in stator 3-phase AC supply is given. Because of this, rotating magnetic field is produced, and as the rotating magnetic is produced, we can see relative motion with respect to rotor. So induced EMF and current in the rotor and rotor magnetic field. So interaction between the two fields, so torque is produced. So due to this torque, rotation is there. Remember, in stator and rotor, there is no electrical connections in between. Rotational magnetic field is there. And due to this field, the conductor, that is rotor bar conductor present over here, as it is moves. So in the rotational magnetic field, due to the flux is changing, EMF is induced in the rotor conductor, and it is as it is shorted, so current starts flowing. The motor is called induction because current is induced in the rotor. No brushes or slip rings needed in squirrel cage type. And this one is very rugged and low maintenance is also there. So single phase induction motor exists too, but they need an auxiliary winding or capacitor to create a starting rotating field. So in our home, our fan is also single phase induction motor, but it is capacitor start. So this simple robust principle explains why induction motor dominate 90%, almost 90% of all industrial electric motor used worldwide. Thank you very much.